I- Hi, this is Radhakrishna from the Department of CSC AIML, rule number 21951 A66 A naught B section. Today's my topic of Tech Talk is exponential distribution, exponential probability distribution. As you see here in the next slide, we are having some of the topic like the exponential probability distribution is useful in describing the time it takes to complete a task. The exponential random variable can be used to describe time between the vehicles arriving at the toll booth and time required to complete the questionnaires and distance between major defects in highways and the time between goals scored in the World Cup, soccer matches, and etc. This is nothing but it's based on the time management of vehicles arriving to both and time required to complete the questionnaires and distance between major defects in the highways and time between the goals scored in World Cup soccer matches and etc. And it's a coming the point of density formula in this probability distribution. F of x is equals to 1 by mu into e to the power of minus x by mu. Here, for x greater than 0 and mu greater than 0. Here, x is greater than or equal to 0 and mu is greater than 0, where mu is equals to mean and e is a value of 2.71828 is a value of e. Here we can get the density functions of probability distribution and communicative probabilities are p of x less than or equal to x naught is which is equal to 1 minus e to the power of minus x naught by mu, where x naught is some specific value of x. Some of the examples of AP full services. A time between arrivals of car at AP's full services gas pump follows an exponential probability distribution with mean time between arrivals 3 minutes. AI would be like to know the probability that the time between two successive arrivals will be 2 minutes or less. Solution. As p less than or equal to 1 minus e2 is a value of 2.71828, which is minus x by mu, which is minus 2 by 3, which is equal to 1 minus 0.155134, which is equal to 0.4866. And the second example is like if job arrives every 15 minutes on average, lambda is equals to 4 per minute. What is the probability of waiting less than or equal to 30 seconds? Therefore, 5 minutes. P is equals to time less than 0.5, which is P time less than or equal to 0.5, which is equals to integration of 0 to 4C minus x by minus lambda which is dt, and which is equals to, and getting the calculations of 1 minus e to the power of minus 2 is equals to 0.86. Some of the characteristics, that means the mean and standard deviation of exponential distribution are equal, and the distribution distribution is extremely skewed, and there does not exist anymore. Distribution of extremely skewed, and does not exist anymore. Some of the graph of exponential distribution with mu is equals to 1. Graph exponential, you can see here. As we see, exponential probability distribution is useful in describing the times which takes completing a task of having exponential random variables can be used to describe time management between vehicles arrivals in rule boats, and time management in having the World Cup matches of soccer balls to scoring the type in time, and time required to complete the questionnaires, and distance between major defects in highways, and time between goals scored in World Cup soccer matches, etc. This is a density function which is used to use the function. As we see here, multiplicative probabilities p of x. We are having the density function having function f of x, and cumulative probability functions having p of x. It is a difference between the probabilities and probabilities between density probabilities and cumulative probabilities. As we see here, the time between arrivals of car is 2 minutes is or less than. Here we having the getting uh, p of x. As we see here, a lot of examples and characteristics. Characteristic, the mean and the standard deviations of exponential distributions are given. When we are considering the exponential distribution, the mean and the standard deviations are equal, and the distribution is extremely skewed, and there does not exist anymore. It is some of the graph which is when the mu is equals to 1. Graph of the exponential distribution with mu is equals to 1. You can see the graph here. Thank you. Thank you.